The piston of a steam engine moves in simple harmonic motion. The piston of a steam engine moves with simple harmonic motion. The crank rotates at 120 RPM with a stroke of 2 meters. Find the velocity and acceleration of the piston when it is at a distance of 4.75 meters from the center. Let's write out the values we have given. The piston of the crank rotates at what?
120.
That's 120 RPM. With a stroke of 2 meters. Stroke.
That's the view.
Stroke. Right? 2 meters. Find the velocity and acceleration of the piston when it's at a distance of what? 0.75. At a distance of what? 0.75 meters from the center. The stroke is the maximum amplitude. That's the maximum displacement. This is a what? A steam engine. A steam engine that has what? Piston. And you know piston is always like this, right? We all know piston is always like this. It will not be inside the cylinder. And it will not be going this way, right? It will be going like this. Going like this. Okay? Are we getting it?
Yes.
Okay. And I know that there is a crank somewhere here. Okay? And there will be something connected like this to a crank. That's the connecting rod.
Yes.
As the connecting rod is connected to the piston, the piston will be moving. This is the piston, this is the ring, this is the piston, this is the ring. So if I say it has a stroke of 2 meters, that means the stroke is, when it goes like this and goes like this, the total distance is 2 meters. Do you understand my point?
Yes.
When it goes like this, you know it's going to go like this. So the total distance is what? 2 meters. It's covering 2 meters. Okay? That means it's covering 2 meters. Going like this, coming back, it's covering 2 meters. So if it goes and comes back, so what will not be the middle? You know the other time I said we drag the spring, the thing will go, come back, go and come back, but it will settle somewhere. Okay? If it goes and come back and it's 2, what will be the middle? It will be 2 divided by 1. 2 divided by 2, it will be 1. So that is how we got that one. That means it's covering a diameter, right? The going and coming is covering a diameter. So the radius will be the total distance over what? Over 2. That is what we refer to as the radius here. That's why we have 2 over what? 2 to give us 1 r. So we refer to these 2, 1 stroke, as the diameter. If we go back, we will see that amplitude, it is the maximum displacement of a body from its mean position. That mean position is when it settles, the middle. So the maximum displacement from that middle is the amplitude. If it goes to the front, 1. It goes to the back, 1, making 2. But from the middle to one direction, how many is it? 1. That's the radius that we need in the calculation. So, okay, I did not put the diagram here. It's the amplitude of the particle. The amplitude is always equal to the radius of the circle. If 1 stroke is the circle, the radius of 1 stroke is 1. So that means 1 is the amplitude here. Okay? So the next one. What else are we given? We are given the revolution per minute. But here we have all the calculations we've done, we did not use revolution per minute. Now we have been using angular velocity, right? W. So if you are given revolution per minute, we first change it to W. W is what? 2 pi n over what? 60. So that's 2 pi 120 over 60. 60 N1, 60 N2. To give us what? 4 pi. So W is what? 4 pi. That's 4 times 3.4, 3.142. Okay. Now we want to calculate what? Velocity and acceleration. To calculate velocity in this type of motion, velocity is always equal to V is equal to what? W into what? R square minus S square. Okay? Okay?
Yes, sir.
Are you getting it?
Yes.
So R, which is the amplitude, X is the displacement. So when we're given that, the crank also find the velocity and acceleration of the piston when it has a distance of 0.75 meters. 0.75 meters is not up to our what? Amplitude, which is 1. If 1 is our amplitude, they now give us a displacement of 0.75 meters. That 0.75 will now be our X, while 1, which is the amplitude, will be our R. Do you understand my point? So it will now be what? V is not what? 4 pi 1 square over what? 2.75 square. What's the answer? So V will now be what? V will be what? 8.31 meter per second. That's our V. That's our V. Are you getting it, sir? Man. You are not getting it. Ask me a question. What? I said a stroke in a combustion engine. A stroke is the to and fro movement. Okay? If something is moving to and fro, if it moves this way, that's half stroke. If it goes back, it's a stroke. Okay? So if it's having front and back movement and it's giving you 1, so the R, the radius, is the amplitude we are looking for. That means we have to divide it by 2 to get the R. So the stroke, I've referred to that stroke as the D, the distance covered. Divided by 2 will give you what? The R that we need. That R is the amplitude in this situation. But now we are not given another displacement that is not up to that 1 as 0.75. That one is lesser. That's the one we use as our X. The one that is bigger is what we use as our what? R. So 1 square minus 0.75 square, all square root times 4 pi is equal to what? V. Now let's talk about acceleration. Initially I said acceleration is what? A is not what? W square X.
Yes.
Right?
Yes, sir.
Now that we are now referring to acceleration, we can calculate acceleration with X. When they said find the velocity and acceleration of the piston when it's at a distance of 0.75. So we can use 0.75 for X here. But if we are to calculate A max, we won't use X, we will use R. Because in some question you will say find the A max. Do you understand? But in this situation we have to find acceleration and velocity when the displacement is 0.75. Since we already know that when the displacement is 0.75, find acceleration, then put 0.75 as your X. But if they say find A max, then change this one to R and put 1. That one is greater than 0.75.
Yes.
Do you understand my point?
Yes, sir.
So now A is equal to W, which is 4 pi square X. X is what? 0.75. So let's use calculator. That's what A is equal to what? 118.46 meter per second square. That's the answer. Are we getting it? Are we getting it?
Getting it.
So, I want to move to the next question. Moving to the next question. Can I move to the next question? Okay. So there's a spring of stiffness 2 kilonewton. Let's say this is the spring. This is the spring, right? It's attached. At the lower end of this spring, we have two loads. Okay. Before adding load, let's say before adding load, this is the length of the spring L1. Then we attach our load. After attaching the load, the spring stretches to this point, because we attach what? Two loads, right? Are we getting it? M1, M2. Let's say this point is what? M3. So the question now says, this is where I want to interpret the question. It's suspended vertically and two equal masses of 4 kg each are attached to the lower end. When you attach two 4 kg, after a while, the thing will balance. It will extend the spring, but it will balance. It will not go up, it will not go down again. It will stay at one point, but the spring will be stretched. But the question is now saying, one of these masses is suddenly removed and the system oscillates. There's no way you remove this one. When you remove this one, the spring will draw this one up.
Yes, sir.
So if the spring draws this one up, then later this one will balance at this point.
M2.
Wisdom.
Yes.
Do you get it?
Yes, sir.
So that means the maximum amplitude right now is L3. But after removal, it will move to what? When it keeps going up and down, it will later balance at what? L2. If you now remove the second one, it will come. This only the spring will balance at what? L1. You get it now? So now the question says, what is the amplitude of what? Of what? Vibration. What's the amplitude of what? Vibration. From these are formulas, and we have to just start. You drop the duster here. Throw it. Just throw it. Okay. From what? It's got the what? M dot what? Is it M dot G or M dot A? Which is what? S M dot G, right? Okay. A is got what? W square X. Right?
Yeah. W got to square. A was
M over X is got to what? G
over D.
over D over delta, right?
Delta.
There's one I'm still waiting for. G over delta. Yeah, okay. Now, what are we to calculate? The amplitude of what? Of vibration. The amplitude of vibration. The amplitude of vibration. The question, in this question we are given what? What is our D? Our D is what? The deflection. Okay? The deflection. If I snap my solution for you, it will be different from what I'm saying in class, because I have solved it long time ago, but the answer is the same. Okay? But you just listen and get it. So now, if the displacement is not known, the mass is known, the stiffness is known, G is acceleration due to gravity, right? This displacement is the maximum amplitude.
So I think we should include S over N.
N over S.
What's it?
Our last one.
The first one is to be S over N. We have to carry
M over S will be what? Delta over.
Yes.
And S over N will be what? G over. Okay?
Yes, sir.
Give you the stiffness X. Let me not go too straight. If I go too straight, I don't like it. You will not know anything. I want to be going too straight, like the way I understand. Let me be saying the reason why I'm doing it that way. Okay? If displacement or deflection of the spring is caused by the what? The weight. Okay? If we remove the weight, the displacement will reduce. It's the weight that dragged this one to this point. It's the weight that dragged it to this point. So if the deflection is referred to as the amplitude that we are looking for, the maximum amplitude, and we are given the weight, which will now be 4 because we have removed 1. So our M now will be what? 4, right? Yes. Our G is what? 9.81. We are given stiffness X as what? 2 kilonewton per meter. So what is our amplitude, which is the maximum displacement or deflection? That is, we got what? 4 times 9.81 over 2. What's the answer?
This one be 2,000. 2,000, sir.
Why is it 2,000?
90.62.
No, the answer they did not convert it.
90.62.
They used it that way.
19.62 kilonewton per meter.
Wait. 4 times 9.81 is what?
39.2.
Where are you now getting 90?
Divide by 2. 19.
Divide by 2.
Yes,
19.62.
yes, sir.
Okay. Nineteen point six two by 1,000 is what?
0.01.
How is it? 0.019. Yes.
All right, sir.
Look at what he's telling me. He said the mass should be 8. Where were you when we were reading the question?
Once again.
Left it.
Yeah.
Where were you? Don't worry, I have the solution that I have written here. You will still snap that one. Because in the solution I did here, I used Bible to explain. There is of the vibration. We know that frequency is 1 over TP. And we know that TP is what? 2 pi what? 2 pi A over X over A. And X over A is the same as what?
M over X.
X over. Where did I do it? I've done it somewhere.
Yes. You have cleaned it. M over X. Attacking the bubble. Kudus. Yeah.
So now what about TP what? 2 pi root what? A over X, right? Yes. What's A over X from the one we did? Check now. Wait. Where is it? Because of L2. Because of L2. A equals W squared. X. Because of L2. I know. board and do it on the board. I already noticed on the board the other time.
That was on the board. You buy it, go to the rest of
Show me. Oh. Okay. Oh yeah. Restoring force over restoring force, disturbing force. FG is got to what? M dot B. FR is got to what? X dot
X.
S dot X is got to what? M dot A.
M dot A.
Okay. So A over X. A over this X. A over X will be got to what? X over what? N. So here now we are having A over X. That's what we have here, right? As our what? What's this? This TP, right? So this will be what? 1 F, right? So if A over X is X over M, that's stiffness over mass.
Yes.
So give us 1 over 2 pi. Stiffness, what's stiffness? Stiffness over M. Is it correct? Stiffness over M, which is stiffness over M, is also equal to what? G over this. That means it's also equal to what? 1 over 2 pi. It's equal to what? Root what?
I'm lost.
G over what? Delta. So to give us 1 over 2 pi. Root what? 9.81 over what? 0.0196. So what are frequency? Frequency, that's N. Hertz.
1.
It's not the one. What's the answer? The answer. What's the answer? Calculator. Calculator.
22.36.
Where did you get 22? That's the answer. So we don't have much time again. I can't be wasting time. So the next one now is to calculate the velocity and what? Acceleration at half amplitude. The velocity and acceleration at half amplitude. The velocity and acceleration at half amplitude. Okay. The velocity and acceleration at half amplitude. When we are talking about half amplitude, we will look for half of that displacement, of that deflection of the spring. We have calculated the deflection of the spring to be 0.0196. That's our data. If the now say velocity at half amplitude, then we divide that one by 2. Okay. When we divide by 2, that's the half. So is that half now that we will now go and use to calculate velocity? When we want to use to calculate our velocity, we will now use the half of it as x. We will now use this full one as r. You get it now? Yes. That will now be what? V is equal to omega square root delta square minus half of delta square. Do you understand it now?
no.
Capture the space. Capture the space. I want to play it.
Yes, sir.
Those are.
So velocity at what? Half amplitude. Velocity at half amplitude. If you need personal tutorial, I can take personal tutorial. If you don't understand, you need extra lesson. They do technical drawing for free. There's nothing free in Freetown.
I know how to do this work.
A point moves with simple harmonic motion when this point is 0.75 meters from the mid part. 0.75 meters, okay. Let's say this is the mid part. 0.75 meters. 0.75 meters from the mid part. Its velocity is what? 11 meters per second. When this point is 4.75 meters from the mid part, okay, let's call this one x1. At x1, the velocity v1 is what? 11 meters per second. And when 2 meters from the center of its path, that means at 2 meters. Okay, let's continue. This is level 1. At now 2 meters. At 2 meters now. That is from here to here. 2 meters. V, this x2, right? V2. The velocity is what? 3 meters per second. 3 meters per second. Find its angular velocity, comma, periodic time, and its maximum n/60. But we are not given n. But we are given velocity, and we used to find velocity as what? V is equal to what? W into what? R square minus what? Okay. We are given velocity V1, V2. We have to find angular velocity. The angular velocity in V1 and the angular velocity in V2 will be the same. It's just the distance covered that is different. Do you understand? But we don't know R. But we are given x1 and x2. If we are given x1 and x2, then let's form two equations. When we form two equations, then we make each equation the subject of formula, which is equal to W. Then if each equation is equal to W, then W is equal to W. When W is equal to W, then we will be left with R. Do you understand? You don't understand what I'm saying? You understand? You don't understand? Eh? Oye. I know you always say oye. We have to find what? Angular velocity. But we are given V1. You know this is how we used to find our V. But in this question, we have V1, V2. And we have to look for W. We have X1, X2. Okay, let's say equation 1, right? V1, X1, V2, W, R squared, S2. Equation what? Equation 2. Looking at these two equations, we know V1, we know V2, right? We know S1, we know S2. W is W. If W is W, then we can eliminate W. How can we eliminate W? Let's make W the subject of formula in equation 1 and equation 2. When you make W the subject of formula in equation 1 and equation 2, let's do it here. Okay, V1, right? Steven, are we getting it? All over what? R squared minus what? S1 squared, right? Is equal to what? W. That's from equation 1. V2 2 over what? R squared minus S2 squared is equal to what? W. If from equation 1 this is W, from equation 2 this is W. If both are equal to W, that means both should be equal to each other. Yes. You get the point. That means, and you see we are getting it now. Yes. So what do we now do? To remove the square root.
Yes.
What do we do to remove the square root?
Square both sides.
We divide this with this with this. Let's divide this with this.
Yeah, divide this 2 by.
That would be 11 over what? 3 is equal to what? R squared minus 0.75 square over what? Right? If we square both sides now, what will happen? Huh? 11 square. What's 11 square?
That's
121 over what? 9 over 9 is equal to what? R squared minus what? 1.75 squared all over what square? Over R squared minus 2 squares is 4.
Yes.
Please, 0.75 squared.
0.565.
5625. 2 squared. 4. Okay. From here we can get R. It's easy. You just cross multiply now and we get our R. Yes or no? No. Huh? You said no. So you can't cross multiply from there to get R.
You can.
You can't.
You can.
Which 2 equations?
No, you got to multiply. I think 120, 121 times R squared minus 4 equal to 9 times R squared minus 0.5.
So how will you not have 2 R in that situation? How will you have 2 R? It's 1 R you still have. But what you say, Jemon no one. When you cross multiply, this one will times this one will times this one. To give us what? 121 R squared minus all this 121 R squared minus 484 because it's equal to R squared times 9 R squared minus 9 times 0.5 9 times 0.5 5.0625. So now we can solve for R. If this is 121 R squared, this 9 R squared. If this one comes to this place, you minus this one from this one.
Yes, sir.
When you minus 9 from 20,
This
will give you 12.
Yeah. Yeah, 112 hours.
When you bring this one here, or when you bring this one here, what will you have?
5.
This one will come here to turn to plus.
Yeah.
To give us what?
2 minus 478.
0.9.
Yes, sir. 0.94.
94.
Yes, sir.
So R squared R not what? R squared will what? 478.94 divided by 112. What's the answer?
4.276.
R squared is what? 4.276. R will be what? Root.
So 2.07. 2.07
07
meters.
So R is R for the 2 equation. That is R. Which other thing are we calculating? W. Now that we already have our R. Now that we have our R, to calculate W will be easy.
Yes, sir.
We know V1, we know R, we know X. When you substitute your R into any equation, maybe equation 1, equation 2, you will get your W, and W is W. Yes. Do you get it now?
Yes, sir.
Let's move to the next one. There's another one that says
Periodic
periodic
time.
time
And maximum.
and maximum time and maximum acceleration. And maximum acceleration. I need to clean the board. One is not what W R squared minus what S1 squared. V1 is what 11. Yes. W is the what? What's our R? What's our S1?
0.75.
Wow.
Fast boy.
So W is what? 11 over root 2.07 squared minus 0.75 squared.
Because
Equals to W. So W is what? Use calculator. I don't have calculator.
11 divided by 3.222.
That is
2.955.
What's the answer?
2.9. Yo, man.
What's your answer? Use calculator. Radians per second.
Okay.
Is it radian?
W is angular velocity, is radian per second. So the periodic time TP periodic time, this is what 2 pi over what W, this is what the what 2 pi into what correct, right? That should be x over a. If W is root a over x, right? That would be x over a. So since we already know W, we don't need this one again. Okay? So we just put it out. 2 times 3.142 over what? 5 points. So TB is equal to what? 1.1 seconds. 1.1 seconds. So now you have to calculate maximum acceleration. A max. This is A. This is A. But A max,
Use our.
we will use R. I've said that initially. A max will be what? W square. A max will be what? 5.7 square times. What's our R? R 2.07. So A max is equal to what? 67.25 meters per second square. So that is it. Yes? What's the question? Let the person recording, let him hear what he wants to answer.
This periodic time, one is we should find the question. So can we make use of that 2 pi over W times? How we are getting our
Now is that not what I did? That's what I did now. The W is 5.7, 5.7, this is 5.7, this is 2, this is 2, pi, this is pi. I just want to put it there so that you will not forget. When you continue to see something, you will know it. Because there will be a time that you will not have something like this to put directly. So that your brain will tell you that you are the one that will put it this way. Yes, what's your question?
Can't you get a
That's true. You are seeing the spring now. Okay, and we can attach the load to it. Consider a closely coiled helical spring whose upper end is fixed, as shown in the figure. Let a body be attached to the lower end. This is the body attached to the lower end. Let AA be the equilibrium position of the spring after the mass is attached. When you first attach this mass, it will stretch the spring. Then later the string will balance and the mass. So after attaching the mass and the spring goes down, goes up, goes down, goes up, it will balance at one equilibrium position. So let this be the what? A. Equilibrium position A. Okay? If the string is stretched to BB, that means maybe immediately you put it, it first comes down to BB. So this point, B, BB. BB. Okay, so the distance between the equilibrium position and this is what? X. So the mass will move up and down with simple harmonic motion. Let M be the mass of the body, W be the weight, that will be M dot A, or acceleration due to gravity, M dot G. X is the displacement of the load below equilibrium position. This is the equilibrium position, but when it comes down, before it settles back, the displacement is what? X. Okay? Why? S is the stiffness of the spring. The stiffness of the spring is the one that is trying to draw the spring back to prevent the load from pulling it down. So the stiffness of the spring, which is in Newton per meter, is restoring force per unit displacement from the equilibrium position. While A is the acceleration of the body. Meter per second. So these are the things I want you to put in mind. Know all this WM, X, S, A. Now, displacement. We know that the deflection of the spring, which is the displacement of the spring, is delta. Okay, which is what? Which is going to be mass times hello? Small. They've just put it here for you. So that's why if you are a student that don't really understand calculation, how calculations are connected, that used to cram formula, you can forget. If I'm taking this course as a student, I won't need to cram all this formula. When I get into the exam, I will be writing everything like this. I will connect everything. So anyone you give me, I will know that okay, G is there, the delta is there. Anyone I will try get the formula. But if you are the type that you just cram this one, if they now give you question that you do not see all this type there, maybe something like this that you need to do before you substitute and before you get the answer, so you will now miss it.
Hello, unfortunate.
One mark, I want to 5/60. So that is it. You can see here, they wrote it there that sometimes the spring used to have its own weight. In a situation where the spring have its own weight, that means you will add the weight of the spring as M1 plus M1 divided by 3. It's in the formula. You've seen it there. Yes. In a situation where you are given the weight of the spring. But the questions I used to set, I've not given them any question that have weight of spring. But in case you are given, so it will now be M, that's the weight that is dragging that thing, and the weight of the spring over 3. That's what you use as your M in that situation. So I think we should solve one example here, then I move to the exam question. I said let's solve one example now here, then I will now move to the exam question that I said I want to solve. I don't think I need to even solve that one. With all these things I've done in class, I don't need to solve it. I don't need to solve it. With everything I've done in class, you cannot, if you are brilliant, you cannot fail the question. Because these are the principles you go and apply. But you may fail it due to interpretation. But if I read the question to you and I explain to you, if I don't solve it, if you are brilliant, you will be able to solve it. So the one I now gave them later, I just tweak some things there. So if somebody that can interpret question, that person should be able to solve it. So let's move to the example 4.3, page 54. Example 4.3, page 54. Example 4.3, page 54. Have you seen it?